Students, in a last part, we have discussed about the physical quantities, types of physical quantities, how to express a physical quantity. And to express a physical quantity, we needed two things: unit and the number. And the relation between unit and number we got to know, that is inversely proportional to each other. Yes, and fundamental physical quantities and their unit and supplementary physical quantities we studied. So now we move on to, in this part, about measurement. So measurement of length we discuss first. Measurement of what? No, measurement of length. So if I look at the range of length, if I look at what? No, if I look at the range of length, range of length starts from where? 10 power minus 14 meter to 10 power 26 meter. Sir, what is 10 power minus 14 meter? It is about a size of an what now? A size of an almost an atom. This is what now? Size of universe. Yes or no? This is about size of a nucleus, a tiny nucleus. And this is universe. Okay. Now measurement of length. Basically, so length we are going to measure what now? Normally in SI system of unit. In what system of unit? In SI system of unit, measure length with meter. That we have discussed already in the previous session of SI units. There are three system of unit: CGS, FPS and MKS. Since there are different units are there, different values are there, so we adopted what now? System of international. Okay, that is what now we are going to accept it and we are going to follow it now in this entire chapter. Okay, so expression is meter. So now sometimes we use kilometer. So as we know, 1 kilometer equal to how much? 1000 meter. 1 kilometer equal to 1000 meter. So in this measurement of distances, normally we use kilometer when you are measuring a distances from one city to other city, or else when you are measuring from one place to other place, kilometer we use. Especially if you are using a scale, normal scale, we use centimeter. So as we know, 1 centimeter equal to how much? How many meter? It is 10 power minus 2 meter. Or we can say 1 meter equal to 100 centimeter. Conversion factor. Okay, this is what we are going to use in the case of measurement of length. Let us understand little different units. When we are going for little more higher order, means now normally daily life we use kilometer, we use centimeter, we use millimeter. As we know, 1 millimeter, that is equal to 10 power minus 3 meter, or you can say 1 meter equal to 1000 millimeter. So little, if you go higher standards, little large unit distances. How to express those large distances? Let us understand those large distances one by one now. So first one is astronomical unit. We indicate AU. So what is meant by astronomical unit? It is the average distance between what now? The earth and the sun is what we call one astronomical unit. That is the average distance between what and what? Earth and the sun. Its value is found to be how much? 1.496 into 10 power 11 meter, and if you round it off, it will become 1.5 into 10 power 11 meter. So how did you measure this? Using what method? Indirect method. Okay, I cannot go for direct method now. Yes or no? I cannot use a scale and to put the scale from earth to moon. It will really funny. Yes or no? So we go for what now? Indirect methods. I'll let you know what are the indirect methods later. Next, other unit is what now? For little large distances, light year we use LY. Okay, so what is meant by light year? It is a distance traveled by the light in vacuum in 1 year is what we call 1 light year. Sir, what is the value of 1 light year? So let us find out 1 light year. 1 Ly, we indicate with Ly. 1 light year equal to, see here, distance traveled by the light in vacuum, means The speed of light in where? Vacuum. How much it is? It is 3 into 10 power 8 meter per second. Okay, meter per second into. In how many? In 1 year. Let us understand this now. 1 year means how many days? It is about almost 365 days on average. So it is 365 days into 1 day equal to how many hour? We need to calculate because we need to get in seconds, right? 1 day equal to how many? 24 hour. So we need to multiply by 24 hour. That is 1 day multiplied by 1 hour equal to how many seconds? 60. Okay, minutes we first. 60 minutes. That is 1 hour equal to multiplied by. Yes or no? Minutes is done now. We need to go for what now? Seconds. 1 second or 60 seconds or 1 minute. 1 minute equal to how many seconds? 60 seconds. Okay. So let me make M just 60 seconds. That is 1 minute. Now tell me what will happen. So here minute and minute is cancelled. Hour and hour is cancelled. Day and day is cancelled. Look at here now. This numerator second and this denominator second is cancelled. What is left now? Unit is meter is left. Anywhere unit is left? No, meter unit. So that is meter. Now if you multiply all these things, 3 into 10 power 8, 365, 24, 60 into 60, you end up with an answer as 1 point, not 1 point, it is 9.46 into 10 power 15. How much you end up now? You get 9.46, that is point it is into 10 power 15 meter. That is 1 light year. So 1 light year means how much distance it is? It is 9.46 into 10 power 15 meter. That is what is the value of 1 light year. So what is 1 light year? Distance traveled by the light in a vacuum in 1 year. Okay, that is one more unit. And understand that one more unit, that is what we call parsec. Even it is a little bigger, or we can say parallactic second. So when we say parallactic second or parsec, it is a distance at which arc of length is equal to 1 AU. Means the arc should be how much now? 1 astronomical unit, and subtend an angle of how much? 1 second. Simply, if I draw this one, look at here. If I take an arc of length, if I take a circle, some arc if I mention, so this is the arc I am going to take, A, B. So this arc must be how much now? The arc length should be how much now? It should be 1 AU. And this will make an how much now? 1 second. Then it is what we call parsec. It is a distance at which arc of any length is equal to what now? 1 AU, and it will form out now, it will form in 1 second. The angle should be what now? 1 second is what we call 1 parsec. If I use this one, if I write the formula for this, see here, theta, that is we know arc length AB by this distance, that is D. Let me call D. Then distance D is must be equal to what now? D must be equal to AB by theta. AB is what, students? 1 astronomical unit. Theta is what? 1 second. Now what is the value of 1 astronomical unit? As we know already, it is how much? 1.5. Average 1.5 into 10 power 11 meter divided by 1 second. I need to convert this 1 second. The 1 second is equal to how much? It is 1 by 3600 into pi by 180 radian. So it is pi by 180 radian. Actually it is. Now if we simplify this one, you get what now? 1.5 into 10 power 11 meter divided by, so 1 second, we get how much? 1 second equal to 4.8 7 or 847 into 10 power minus 6 radian we get. Okay. Sir, how did you get this value? 4.847 into 10 power minus 6 radian. We will do that one. Okay, we will do the conversion. One small numerical will do. Then you will get to know. And simply, okay, this is the answer you get for what now? 1 parsec equal to how much we got now? 1.5 into 10 power 11 meter divided by 4.847 into 10 power minus 6 radian. I can write this one as, that is 1 parsec, right? That is distance we are doing now. So distance, that is equal to 1.5 into 10 power 11 meter divided by, it is, make it an approximation, it is 4.85 into 10 power minus 6 radian. And if you simplify this one, you will get as an answer is how much now, as 3.08084 into 10 power 16 meter, or you can write just simply 3.1 into 10 power 16 meter. That is the value of what now? 1 parsec. So we are using three things now here. One is astronomical unit. Yes or no? What is astronomical unit now here? It is the average distance between the sun and the earth. Light year, distance traveled by the light in 1 year in a vacuum. Next, 1 parsec, it is the angle made by the one astronomical unit of 1 second, or you can say a ratio of what now? 1 AU by 1 second. Now here one doubt you have now. The doubt is, sir, how did you take this 1 second as 1 by 3600 into pi by 180 radian, or you can say 4.847 into 10 power minus 6 radian. Okay, let us do a small numerical to understand this conversion from radian to second. Okay, look at here now. They are asking you to calculate the angle of 1 degree, 1 minute, 1 second in what now? In radians. Okay, in what now? In radians, given that 360 degree equal to 2 pi radian and 1 degree equal to 60 minutes. So if 1 prime is there, it is minutes. If double prime is there, it is seconds. So 1 minute equal to 60 seconds. They are given this one. Now we need to use this one in order to what now? In order to convert. So now as it is given already to us, 360 degree equal to 2 pi radian. Now we want 1 degree. So can we just simply divide both sides by 360 here and here? So divide now. It is 360 degree divided by 360 equal to 2 pi by 360 radian. Now it has become 1 degree. 1 degree equal to 2 by 360 is 180. So it will become pi by 180 radian. So we got now 1 degree. So 1 degree equal to how much now, students? Pi by 180 radian. So we got it here now, this one. Pi by 180 radian. So that is also given by what formula? Pi by 180 means how much? Pi means 22 by 7. So it is 3.142 divided by 180. That is equal to, or you can say radian, that is equal to, what to get an answer? You get an answer as 1.745 into 10 power minus 2 radian. So this is about what now? 1 degree. Now second thing is what now? Check it. Second thing is what now? Second thing they are asking you to calculate 1 minute. So use this 1 degree now. Here I am going to use now 1 degree. Now 1 degree, that is equal to how much now we are using? Pi by 180 radian. So we use pi by 180 radian, or you can take this directly, this one, no issues. Okay, Yeah, so 1 degree equal to this much, we got it now. Now we want to find 1 minute equal to. So as we know, 1 degree equal to how many minute given here already? 1 degree equal to 60 minutes. So can I replace this 1 degree by 60? So it will become what now? 60 minutes, that is equal to 1.745 into 10 power minus 2, or can use this one, pi by 180 radian. Not an issue. It will become what now? Pi by 180 radian. You can use either this or this, no issues. Both are same thing. Now we want to what now? We want to have 1 minute, so I will divide by 60 again. 60 by 60, that is equal to pi by 180 into 60 on both sides. Radian, it will become what now? 1 minute, that is equal to pi by, this is 180 into 60 radian. So if you simplify, you get what now? You get as 1 minute equal to pi by, pi means how much? 3.142. So 3.142 by 180 into 60. So you get what now? Finally you get an answer 1 minute equal to 1 minute equal to 2.908 into 10 power minus 4 radian. How much you get? Into 10 power minus 4 radian. How much you got now? 1 minute equal to 2.908 into 10 power minus 4 radian. So we got two things now. What now we got now? Look at the question now once again. Calculate 1 degree. So we got 1 degree. 1 minute or minute of an arc or arc minute. We got it. Now last one we need to find out what now? 1 second. So let us go for that 1 second now. So now what is 1 second? Given the question, 1 second, that is equal to, okay, not 1 minute equal to 60 seconds. So we use this one now. 1 minute equal to 60 seconds. Now we use here the concept of previously we got here. What answer we got here, students? Look at here. 1 minute equal to 2.908 into 10 power minus 4 radian. Now see. 1 minute equal to how much given? 60 seconds. So we use 60 second equal to 2.908 into 10 power minus 4 radian. Now we divide what now? We divide by 60. So it is 60 by 60 seconds by 60, that is equal to 2.908 into 10 power minus 4 divided by 60 radian. So it will become 1 second. 1 second equal to, if you simplify this one, you get an answer as 4.85. I am making approximate to into 10 power minus 6 radian. Or if you use in terms of what now, this pi by 180, in terms of this, you get what now? 1 second equal to pi by 180 into 3600 radian. Simplify this, will get same answer. So this is the conversion. This is a conversion from where? 1 degree, 1 minute and 1 second. So this we are used in a case of previously parsec. So 1 minute equal to how much? 1 second equal to how much? We used this term. Which term we used? We used this one. 1 second equal to how much? 4.85 into 10 power minus 6 radian. Okay, this is the one more thing. Now we'll go for a one more method, that is indirect method. What I told you, to express the physical quantities, like to measure the physical quantities, indirect method, we focus on that. One method is what we call parallax method. Okay, so what is meant by parallax? You need to understand this about parallax here. Do one small experiment or activity, what we call, to understand about parallax. Simply hold your pen in such a way that in front of your eye to eye level. First you close one eye and look at the pen nib, and then open that eye and close another eye, look at the pen nib. You feel like what now? You feel like the pen nib is moving actually, but not actually you are moving. You are holding it fixed, but you feel like it is changing its position. That is what we call parallax. Okay. Now this method we are using to measure what now? Measure the distances of planets and the stars. From where? From the earth. Now parallax means what now? as we done the activity, it is a relative shift in the position of an object with respect to background. You can pause the video, you can check once. Definitely the pen will start moving here and there. It will start shifted. That's the reason what we call parallax. Okay. Now the distance between two a point of observation, right? So you are observed from one side left eye, one time with the right eye. That distance is what we call basis. That is the distance between points of observation. Okay. If I write a small diagram for this, look at here now. Look at here now. Here from this and from this point, I'm going to observe what we call, let me call point is P and point is B, A and B. I want to look at here. There is a star here, let me call yes, and this angle is what we call angle theta. Okay, this angle is what we call parallactic angle. So what we call this angle, students? This angle is what we call parallactic angle. Okay, and the distance between these 2 points A and B is what we call basis. We indicate B or D, whatever basis. And the distance from this point to this point is what we call D, the point of observation to where we are looking. Then imagine it is like a center of the circle and this is like an arc length. Then from the plane angle definition, can we write the theta equal to arc length by radius of theta? Arc length is AB, that is what we call basis, divided by distance is capital D. So basis we indicate small b, so it will become what now? B by capital D. So we want capital D now, D equal to B by theta. So this is the formula we are going to use. So B means a distance between 2 points of observation. It may be anything. Okay, if I start observing, imagine there is a earth. This is what now? This is earth now. Then it will become what now, the students? It will become diameter of the earth. So here in the place of B, I should use no diameter, no? That is what we call diameter of the earth. So this is what we call measurement of length using parallax method. Okay, simple observation, simple thing. Okay, this theta how we are going to get, sir? By experiment. Okay. Now we look at one more thing, that is measurement of what now? Mass. Okay, the range of mass is from where? 10 power minus 30 kg to 10 power 55 kg. What is 10 power minus 30 kg? It is about what now? Mass of electron. Mass of what now? Mass of electron it is. It is what now? Mass of the universe. The biggest thing we know universe is the mass of the universe. Okay. So that is a mass range from where to where? 10 power minus 30 kg, that is the smallest one, and the highest is 10 power 55 kg, that mass of the observable universe. What we see, that much only we are considering now here. Here some of you ask me, sir, it is expanding now, sir, universe is. Then how can we say? So what we see till where we see, that much we got is now 10 power 55 kg as of now. Okay, some other practical units are there we use in the case of measurement of mass. Normally what we use, expression for expressing a mass, we use kg. That is what type of system? That is SI system. So sometimes we use a grams, that is actually CGS for small. Sometimes milligram, especially in chemistry lab you use milligrams, mg, milligrams, even small. Milli means how much here? Milli means 10 power minus 3 grams. Okay, so that is the thing. Normally we use kg as a SI system. Then some practical units are there. One is atomic mass unit, what we call AMU. Sir, why we need to go for this? Why can't we use kg here? Kg become inconvenient because these masses are very small, especially in the case of nuclear physics. If you are measuring the mass of the nucleus, electron, proton, all those things, this will become little inconvenient. So we are going to use some other units. What we call, one is atomic mass unit. Then atomic mass unit is used to express what to measure atomic and nuclear masses. Sir, what is the definition? It is defined as what now? 1 by 12th of mass of one carbon atom. How much it is? 1 by 12th of mass of each carbon atom is what we call one atomic mass unit. Then we can write this one, students. What we can write this one? as an atomic mass unit? 1 AMU, 1 AMU, 1 AMU, that is equal to 1 by 12th of mass of each C12 atom. That is, so if I do this one, 1 AMU, that is equal to 1 by 12th of, so mass of each 12 atom, how much it will be there? No, it will be, see here, simple way. So it is about 12 divided by 6.023 into 10 power 23. Sir, how did we get this one? It is in grams now. It is in grams. How did we get this one? Because we know 1 mole of carbon. Okay, 1 mole of carbon is equal to how much? 12 gram. Okay, 1 mole of carbon is how much? 12 grams. So each mole containing how many number of atoms? Avogadro number of atoms. It will become 6.023 into 10 power 23 atoms. Then, so 1 mole containing 12 grams, that is equal to these many number of atoms. Then we want a mass of how many here? Mass of each atom. So I am going to divide 12 gram by this much. So total number of mass by total number of atoms will give us each mass, each mass of the particle. So if you simplify, you get what now? 1.66 into 10 power 27 kg. How much you get, students? 1.66 into 10 power minus 27 kg after converting gram to kg. Okay, it is actually minus 24 grams. Okay, to convert into kg, it will become 1.66 into 10 power minus 27 kg. Okay, this is what now? Mass of what now? Mass of 1 AMU. That is 1 AMU equal to how much kg? 1.66 into 10 power minus 27 kg. So please do remember this one. You are going to use this one when you are going to study about nuclear physics. Okay, when you study about nuclear physics, you definitely use this one. Okay, let us do one numerical, one or two numerical based on what now? Based on the parallax method what we saw. That is a distance measurement, for distance measurement. Now the moon is observed from two diametrically opposite points, what we call A and B, on the earth. So means the distance between the 2 points of observation is how much, students? It is equal to diameter of the earth. The angle subtended is how much, student? By the moon, it is 1 degree 54 minutes. Given that diameter of the earth is given 1.276 into 10 power 7 meter, and we need to compute what now? Compute means what now? To find what now? The distance of moon from the earth. Now let us do one by one thing. Now given is what now here? Theta is given, angle is given. Theta is 1 degree 54 minute. Now we know 1 degree equal to how many seconds? How many minutes now? 60 minutes. So we know 1 degree equal to 60 minutes. So we use now, it is 60 plus 54, it will become 114 minutes. Theta equal to how much now? 114 minutes. So we got it now. We need to convert 114 minutes to what now? Seconds. So we need to multiply 114 into, it will be 60. It give us what now? It will give us 6840 seconds. So we got in what now? Seconds. Now we need to convert into radian, because you know the formula. What formula we know? Theta equal to arc length, that is a basis, by radius, right? That is distance, capital D we are using. So now we want a D, that is basis B by what now? Theta. Theta should be used in what now? Radians, not in second. So we know 1 second equal to almost as how much it is? 4.85 into 10 power minus 6 radian. Then 6840 seconds, that is equal to how much, students? That is equal to, see here, 6840 40 seconds into 1 second equal to 4.85 into 10 power minus 6. Why I am doing this method? See, second is going to cancel. If you simplify this one, you get what now? 33174 into 10 power minus 6 radian. Or simplify, you can this one by shifting this decimal places here. You can get some other value, also not an issue. Now we need to find this value. Let us do this value here. D we need to find out distance. So B means basis. How much is given basis? 1.276, that is distance between 2 points of observation into 10 power 7 meter, divided by theta. How much we got? 33174 into 10 power minus 6 radian. So if you simplify this answer, you get what now? 3.84 into, okay, I think it's not visible. Yes, 3.84 into 10 power 8 meter. So that is this much. That is what now? Distance of moon from the earth, making an angle of how much, students? Making an angle of 1 minute 54, okay, 1 degree 54 minute. So this is a way of calculating using a parallax method. You just remember this formula, where theta is a angle, basis means a distance between 2 points of observation, d is a distance, actual distance from where? From point to point of observation. Okay, from the where you are looking, the star or whatever it is. Okay, you can, in the place of star, they can ask you what is even in the place of moon, they can ask you star or any other thing. Basic what you should remember this formula. Okay, so this is about the concept of measurement of length, mass and parallax method, and some other practical units of length and mass, and there is a one small numerical related to what? No, related to calculation of distance using parallax method. Okay.